Hi guys, so we're gonna do CodeForces 1793D Moscow Gorillas. So well, basically, how do we do this question, right? What they want is basically given two arrays P and Q. You're gonna find two L and right points, the number of L and right pairs that basically correspond to indexes pointing to P and Q array positions that would basically have the same max value. Max value basically is the smallest positive integer. So to illustrate what I mean, if your L and R is 0 and 2, the max for both would be 4, so it would be the same, right? So if another example is if your max was 2, so this would be the two subarray permutations generated, then your max value would be 1 in both cases. So another correct answer is this. The whole array is always going to be one correct answer because the P and Q is going to be from 1 to n, values 1 to n in distinct integers as well. But it can be in any order, which is what makes this question quite difficult. So where's the third permutation that works for this? Let me see. 1 3 3 3 equals to 4. Oh, the answer is 2. Okay, yeah, so we were correct. Okay, so yeah, so I guess to do this question, I tried to create some examples here, but this tool I find does not work that well. So basically, to understand this question, I'm just going to use maybe text edit to explain, right? And basically, what we're gonna want to find is we're first gonna want to find the. So imagine a bunch of values, and then you have 1, and then next you have 1 and a bunch of values, okay? And just assume that these two arrays are basically identical. Then you have 1 and 1 here. So what we want to find is this area here, everything before the 1, because then the max will be 1. So all the permutations possible. So let's say there were 3 values before this 1 here, right? So there were 3 indexes before 1, alright? So 1 is an index 4, for example, right? Then the number of possibilities for that array, number of permutations would be 3 times so it's basically 1 plus 2 plus 3, so 3 times. So if you simplify 1 plus 2 plus 3, it's a recurrence relationship, which is basically n times n plus 1 over 2. So it's 3 times, n times n plus 1 over 2, right? If this is 3 values. Now assume the same thing here. Let's say it was 2 values, so it's 1 plus 2, but in any case it's going to be again n times m plus 1 over 2, which is going to be equal to 3. In this case it will be 6. So in both cases, this and this, the max will be 1 because it excludes 1 basically. MEX will be 1. MEX, when I say max, I mean MEX, minimum positive integer. Now you also need to calculate the values in between here, right? Because that excludes 1 as well. So the max will definitely be 1, right? So let's say there were 4 values. It does not really matter. So again, same formula, you'll get 10, right? Because 4 times 5 over 2 is 2 times 5, so it's 10. And basically, yeah, that's for 1. There's one more that you missed out though, which is plus 1. Why? Because this includes the whole array when you just start from the starting 0 and n. 0 and n minus 1, I mean, right? Basically, right? So that's for a start. Now, once you go to 2, okay, there are 3 possibilities for 2, right? Where in terms of where the 2 array can be placed, that whereby it will matter. It can be placed anywhere, but if it was placed like here and here, it wouldn't matter because there's no way to create a situation whereby you include 1 but you exclude 2. because if in here 2 will be, you include 1, so you're trying to make 2 the max effectively, right? So from here onwards maybe, right? And just imagine the same area as being highlighted. But the problem is that 2 is inclusive here, so it won't work. Now if 2 was not here and say 2 was here and here, it will be the same thing, right? Try to include it but 2 is here. Try to maybe do it this way, whereby include 2 but 2 is here. So what are the ways that 2 can be situated such that 2 can possibly be the max? And the answer is, if it's here and if it's here, it's possible, right? This region here does not include 1 and 2, so the minimum positive integer, no, sorry, I was wrong. Here and here, okay, let's say that 2 was, yeah, it's basically the same, but basically if you include this area and this area, basically 1 will be included and 2 will be the minimum positive integer. So that's the first position. So let's just record that down. Now what's the other position that's possible? Okay, if 2 was here and 2 was here, okay, it doesn't really matter whether this 2 or this 2 came first, it will be the same. Basically when it's greater than the maximum, when the larger pointer, okay, let's call it maximum, let's call it right, okay, call it right, yeah, when it's greater than right, then basically this area here, whereby you don't include 2, the max, the MEX will be 2, minimum positive integer will be 2, right? So basically you need to calculate the difference between here and here as well as here and here, because those are the ways in which basically the subsegment permutations can be expanded, whereby 1 is included, but yeah, whereby basically 1 is included but 2 is not going to be included. So the third possibility whereby it will be included is if it is here. Okay, so again, this possibility basically, so you need to calculate the difference between here and 2 as well as here, because these are the ways that basically 1 can be included. So this entire small segment times multiplied by here, right? So those are the 3 methods whereby you can be included. And every single time we look through this, we need to update the new positions of the left and right pointer, because now when we go to 3, let's say we got this at 2, right? Then the new mean value is going to be here, right? So that when you go to 3, where you get 3, it's gonna, because for 3 the max has got to include 2, right? So basically the same idea, 2 has got to be included, so the new mean and max values are now 1 and 2. So that's basically the intuition for this question. So I already gone ahead and written some code here, but let me just delete them as far as what's not needed, so that we can develop an understanding of it from scratch. So right now what I did is I just read in the code, which is N, P, and Q, right? Okay, and that's like the most basic stuff. And I imported this thing called counter, but I think the better one that we need is default dictionary. So what this does is basically a dictionary for us, and what it does, instead of the normal dictionaries, if the key doesn't exist, you'll just create one for us. So for I in range n, and by the way, we're going to create a new called indices default dictionary list. Alright, so indices key I dot append I. So what this do is for every value within the P and Q array, we are going to append the index to it. Okay, now let's just print indices real quick so that we can see what we got. So you can see it's all in increasing order, and the reason why is because we are appending it from 0 to n, so the smallest value always gets appended first, so 0, 1, 0, 2, 1, 2, etc. Now after we got that done, now we need to let me think what we should do. Okay, I think what we can do is we can create an A and B value, which basically corresponds to indices. Let's see. So we have 1, 2, and 3. Indices 1, and I'm not sure if this extracts the let's take a look. 0 and 1. Okay, which is correct. Yeah, pretty much. So this is the initial like pointers here that we got for these two 1, 1 values. And next thing we're gonna do is we're gonna create a new function called we call it anything we want, but maybe I'll just call it summation, and we are going to take in a value of n, we can call it n, to reduce ambiguity, we just do m. So return m times m plus 1 over 2. So yeah, I think this should be correct. But yeah, okay. So actually this bracket wasn't needed, but anyways, so we're gonna have an answer which equals to 0. So answer plus equals to actually we can just straight away equate it to summation of, now this is getting a little bit tricky because we need to make sure that it's sort of correct. So if it was at the 0th value, if 1 was at the 0th value, so if 1 was here and the other one was, let's just say, at here or something, but the number of dots don't correspond to the number of elements, okay? It's just a visual representation, right? Oops. So if 1 was 0, how many permutations of arrays before it came can exist before it? And the answer is it's 0. So basically you put 0 here. Now we need to calculate the area from n to here. So summation of n to m minus b minus 1, I think, because basically when it's 6, m minus 6 minus 1 would be 0, which is correct, whereas when it is 5, m minus 5 minus 1, you will get 1, which is actually correct as well. Oh, by the way, what I mean is, like, when there's one value from the n, then you should get a 2 value, that's why you be minus 1 here, plus summation of b minus a, which, let's say that it was I think it's not b minus a, is it minus 1 as well? If b was at 2 and a was 1, it would be 0, but you get 1 value from b minus a. And if it was 1, 1, then you will get a value of minus 1, which, if we do this, minus 1 times 1 over 2, minus 1 times 0 over 2, which will give me 0. Okay, so that's very neat, works out. So let's print the answer to check, and we get 1, which comes from this area here, right, whereby the max is basically 1. And we're going to add a 1 here, basically because we haven't accounted for when it's just going to be the whole array in both cases. So when you start from the 0 to the n value, so that's not accounted for, right? So the answer is 2. So actually for this problem, that's the only thing you have to worry about. So for this test case is when we start to worry about the 3 cases that we discussed earlier. So we're at 14 minutes now. So okay, we have a and b now, so let's look through it. So we're gonna do from 2 to n plus 1 because those are the values, 2 to 7 in this case. And so if, okay, first of all, we need to take out x and y, which will be indices I, right? So print x and y. So let's just do that first. And okay, so 2, 3, 1, 4, okay, it's all correct. Very good. So if y is okay, let's talk about the three cases that we discussed. And I think I just erased one of them, but it doesn't matter. Okay, let's start from this case first. Okay, if basically if x is greater than a and y is lesser than b, am I right? X, y, yep, pretty much. So we need to expand the array, which in this case would be oh, by the way, this is not 0, this is summation of a. What am I doing? Hang on, let me check this again. Yep, 12. Okay, as you can see in this example, it is 12, it's correct. So okay, let's talk about the three cases here. If x is greater than a and y is lesser than b, then what we're gonna do is we're going to basically expand the area by this and this amount. So we're gonna take this minus this, the difference minus this. So if it was a value of, if it was right next to each other, the value would be 1. So 1 times 1 is 1, which is correct, because you would just increase the number of the possibilities by just 1, basically, when you include the 1 values on both sides, because they basically have to be included. So yeah, so we'll take answer plus equals to y minus b, sorry, b minus y times x minus a, right? So else if x is greater than b, answer plus equals to you have to increase it by this amount to increase 1. So if it was if 1 was at 0, then you would not multiply by 0, you multiply by 1, because there's nothing before it. But if it was at position 1, you multiply by 2, because you have the option of starting from 0 or 1. So a plus 1 multiplied by difference between here and here. So but I don't think it's x is greater than b. Wait, is it? For this case, x is greater than b. Yeah, it is. So a plus 1 b minus x. Wait, hang on, is this correct? You mean x minus b? Yep. L if y is lesser than a, which is this case here, x, y is lesser than a, answer plus equals to again n minus b in this case, because if b is 6, n minus b is 1, which is correct, multiplied by a minus y. And now what we have to do is we have to remember to set the new a and b value. So it's going to be min a and x, and b equals to min b and y, basically. Right, so 20, that is wrong. Okay, because the answer here is 16. Let's see. This was correct, and we're using a and b values here. So let's print this answer here and print x, y, and answer maybe here. Okay, Oops, sorry. Okay, so 12, 14, and when you're at 6, 6, it suddenly becomes 20. So you're talking about these values here. So these values here, x is greater than b. Okay, so x is greater than b, a plus 1, hang on a second. Okay, let's just confirm it's here. I think that was the problem because 6, 6, 20. Let's print a and b as well. 1 and 3, which does it correspond to those values? 1 and oh, I know why, because you're not resetting it correctly. It should be maximum value. Okay, looks 1 and 5. 1, 2, 3, 4, 5. That's correct. Hang on a second. Maybe now we have to print this. 12, 16. Yeah, that's. Hang on a second. 12 is correct. Let me check. Hang on a second. Let me just do it here again. 2, 3, 4, 5, 14. So okay, so it adds values of 2 because you have to expand it by 2 values here or by 1 value here. And then when you go to 6, 6, 1, 5, 15. Oh, there's another one. 3, 5. That's the problem. It occurred when it shouldn't have. 0, 1, 2, 3. 0, 1, 2, 3, 4, 5. Huh? Wait a sec. Print. Let's print the indices. 3, 5. That's very strange. Do we have a 3, 5 here? 5 is at 3, 5. 0, 1, 2. Oh, 3, 5. Okay, 5. And now it's 1, 6. Wait, was I wrong about this? If it's in between. Man, I was completely wrong about this. Shit. Okay, so it's actually when it's outside. Dang. Right? Hang on a second. If it's in between. Oh no, you're actually supposed to include this value, then the max will be 2. My god. So yeah, this is not only wrong, the calculation is going to be wrong as well. So if x is lesser than a and y is greater than b, right, and it's not going to be this, it's going to be this is quite bad. Yeah, horrible. So if y minus b times a minus x, basically. Okay, so now it seems to look correct. Let's try with this. Yeah. Wow, dude, that was an embarrassment. Let's just comment out everything. And let's try again with this, make sure. I'm actually printing out this as well. Oh no, I'm not. Yeah, it's just okay. Okay, let's give this a shot. There seems to be a lot of tests. And finally, it's accepted. Right, that took a while, man. Not an easy question for me. Anyways, thanks so much. Have a good day. Bye.